Good afternoon. Happy Thursday. I hope everyone's doing well. And welcome to our webinar today, where we're going to take a look at Creo's Reverse Engineering Extension. My name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI. It's good to have you today. And leading the webinar and the presentation and the demo is Paul Dye, who is a solutions consultant with PTC at the Virtual Center of Excellence, and he is also an applications engineer. So Paul will be leading us today. If you have any questions, put those in the Q&A box, and we'll try to answer those as we go along. And I'll also be recording this and sending out the recording to everybody who registered sometime later today or first thing tomorrow. So without further ado, Paul, take it away, my friend.
All right. Thank you very much, Rob. And thanks for having me on. It's a pretty cool
Absolutely.
extension that we're going to go through today with the reverse engineering extension. If you don't know me, my name is Paul Dye, of course. I'm a solutions consultant and application engineer here at PTC. And I work with pretty much all the different extensions of Creo. And this is definitely a cool one and very, very useful for a lot of people, depending on the use case that you're working around. So I'm going to go through and explain how we like to use it, what situations that it's helpful for, what it looks like from within the context of Creo, and take you through that workflow. So if you have any questions throughout, feel free to drop those in. Anything that you want to look further into, or if this is something that you really see yourself using, we could definitely have further conversations around and maybe get something a little bit more tailored to your use case. So without further ado, I can go ahead and jump into it. Now, before I talk to the main capabilities and really show anything, I want to start to go over some of the main challenges that we really see this being used around. And the first thing you always need to be able to do whenever you're working with designs is define and capture design intent. So anytime that you're working with a model that's been scanned, something that might be in real life that doesn't have a drawing or model associated with it, or just a tessellated geometry that you might have, you don't have a lot of that. All you really have is just a bunch of points floating in a coordinate system, not something that's really usable geometry per se, but you need to be able to make use of that data. And what you really need to be able to do is drive that geometry using math, relations, formulas, things that allow us to have more parametric control over the model. And if you want to make 3D models of your data that you're scanning in, you need to be able to take all that data that you scan and getting it into a form that you can actually work with and drive with your dimensions, relations. And at the end of the day, for this to really be useful, you need it to be precise, mathematically correct geometry, because it's great to be able to look at something that you scanned in, it might look good, and it's faceted, tessellated geometry. That's what you oftentimes get with point cloud data. But whenever it comes to making real manufacturable surfaces that you need for those models, you need something more. You need something that's going to be precise, curvature, continuous geometry, things that you could mill, cast, 3D print, however you want to go through and create that from that 3D model. That's really what we need to get to. And that's what the reverse engineering extension is allowing us to do. So in short, it's our tool from within Creo for taking your scan point cloud data. Yeah, go ahead.
Paul, sorry to interrupt you, but there's something funky about your audio?
It might be the Zoom settings may have switched my audio. Let me go ahead and check on that for you.
Okay, thanks, buddy.
Yeah, we caught it before we actually getting to, so thanks. We should sound a little bit better now thankfully before we get into actually really showing a lot of the capabilities. So that's what I'm gonna go through now and do, is talk to what we're really working with here in reverse engineering. So in short, we're taking in scan point cloud data, we're taking in, editing it, refining it, analyzing it, and at the end of the day, getting you to real manufacturable geometry that has design intent behind it. So there's going to be three main phases that I'll walk through from within this process. So step one is going to be the point phase. Anytime that we actually want to bring in that data, we have to be able to get it into Creo. So there's a lot of different options that we're going to have here. So we're starting with that point set data and bring it into Creo. And once you have it in, have the ability to go through and clean it up, get rid of inaccurate data. You can also reduce the number of sample points to speed up the computation time. And in general, fixing up any areas that may or may not have been scanned in perfectly. And once you have that data brought in, you would move next into the wrapping and faceting phase. This is going to take that point cloud data that you brought in, and we're going to create a faceted shape almost wrapped around that data. And throughout this, you're still going through and removing any inaccurate data that may have happened because of the scan, filling in any gaps that you might have to get to more of a watertight model. So the main point of this is to get a much clearer view of what that underlying geometry is meant to look like, helps us to gain a better understanding of the model as we start to move forward and refine the shape of that model. And that's going to be moving us into the third and really main step from within this process is going to be the surfacing phase. At the end of the day, reverse engineering is very much a surfacing tool for getting to that real manufacturable geometry. So real true Creo surfaces that you can make use of going forward. And we're going to first, and you'll see this a lot, is I'm going to start by building up curves on top of that point cloud data. We're defining the areas or domains that we want to build around. And then from there, creating and modifying the surfaces from those curves that we built. And once they've been built, you have different diagnostic tools to give you different information on how the surfaces that we've created are acting, how smooth they are, any areas that might need to be cleaned up, and overall just analyzing to make sure that the curves that we've created are really working as they should. One thing that you'll see me use a lot of times throughout this process is going to be what we call domains. A domain is going to be a collection of faceted points that are bound by either one or multiple curves that you have laid out in the data. And domains are very useful for creating surfaces, but also for analyzing the geometry that you built out. So there's different options that you have with these for creating, adding, removing loops that define those domains. And once you start to have some of those defined, you have options for merging them later on. So again, all really helping us to work towards very precise and at the end of the day, very quality surfaces that we're going to have for that 3D geometry. So very useful for us. And again, I'll go through and show what this all looks like from within the context of Creo here. We'll walk through a basic workflow of what it looks like to start with a point cloud, bring it in, clean it up, get it into our environment, and then create some services off of that. One thing that Rob mentioned is that it'd be very cool to be able to see a real life example of scanning something in and then bringing that into Creo, which would definitely be pretty cool because that would take us really end to end of starting with something in real life and bringing that into the Creo environment, which is what you'd really be doing with something like this is you'd have an actual 3D scanner, or you could even use a LiDAR scanner that a lot of people have on their smartphones nowadays. You can really start from a lot of different areas in terms of the point clouds that we're bringing in. So definitely a very real life case that this would help for, and it's maybe something that we could start to expand on in the future here. But from within our use case here, I'm just going to go ahead and start from within the context of Creo. And we're going to start with the scan data that's already been done out in real life. And I'm going to be working here on our Polaris snowmobile data set. I'm going to be focusing in here on this seat part. And what we're starting with is a point cloud that maybe I work for a company and one of my industrial designers scanned in or constructed elsewhere in real life for the seat cover. And what we want to do is take that data and then build a part off of it right here in Creo. So we don't really have anything else but that scan data to build from. So we're going to go ahead and bring that in and create the surfaces that we'll need to construct the seat cover. All right, so we have some different options that you have for the import type. In this case, we're going to create faceted geometry from these points. Like I mentioned earlier, you have options here whenever you're bringing this in to change the sample for what you're working with in terms of the points. A lot of times when you work with scan geometry, you're going to have tens or hundreds or even millions of different points that are being brought in as part of that scan. So what you have the option to do is decrease the number of points that you're using to reconstruct that geometry and just lower down the density, but still keeping a good understanding of what's happening with this underlying geometry. So you have some different options whenever it comes to sampling those data points. And once you have those points brought in, we can take a look at the faceted geometry that we have here. And this is where we can really go through and inspect the model. You can see if we have any gaps or holes anywhere. And if we do, it's very easy from within here to fix that up from within that reverse engineering process. And really in general, just taking whatever steps necessary to clean up that geometry and making sure that it matches up well with that point cloud that we started with. All right. And with that, we're pretty much good to go. We can go ahead and take that. So all we really need to do from that point and facet phase. And now we're going to move into the main surfacing phase here. We're going to focus back here on the point cloud data that we brought in. And any areas that you are going to work with here from within our reverse engineering process, you can see it's going to be under this restyle tab. So it's just an option from within your surfacing options up in the top ribbon commands. And all of our different reverse engineering capabilities are going to be contained from within this restyle feature. And we can go ahead and get started with this. And just from looking at the part, it's pretty clear that this is going to be a symmetric part. So what we can do first and foremost is define a symmetric plane that we can then mirror about later on. So just really helping us to focus over here on one side of the seat and not have to duplicate that work onto the other. So first thing we'll do is build out a section curve here. It's going to be the base that we'll start to build off of as we keep going here. And that's what I'm going to be doing over and over in this process, is starting by first and foremost building out curves, then defining the domains that we want to work around, and then from there creating the surfaces to outline the geometry that we have from that point cloud data. All right, the first point that I have here, the first curve that I'm building out, is going to be along that first section curve, and it's going to be right along the initial surface that we started with. But you do also have different options if you want to play with it a little bit, modify that, make them into whatever shape that you're looking for to better align with that point cloud or whatever the geometry needs to be. So one thing to note is that you will start with the point cloud, but you're not necessarily just stuck with it. You can do whatever you need to make modifications if need be. Simply move around the points until you're happy with the result. And we're good to keep moving on here. And what I'm going to do is create a couple other curves here to outline the surface that we want to create. And this is going to be outlining the underlying geometry. Going to do our best to align with the curves with the geometry that we started with. You can really get as detailed or as loose as you'd like to. It's up to you how you want to lay out those surfaces. Here you can see that we have those domain of points in the middle that'll help us. I'll get a little bit more into that later. But what I want to do now is just define a little bit of detail here. We can add in a few more curves going in the other direction. We can finish that up with one curve going through the center line. And now that we have our defining curves laid out, we can just build a surface simply by selecting all the different curves that we created based off of that point cloud. And once we have all those selected here, you can see the start of our surface. You do have different options from here to edit the number of segments that it has, either increase or decrease the number of segments to define whatever level of detail that you need to get to. And while I'm working, you can notice over on the left-hand side, you have a restyle tree, which lets me know everything that I've done or created up until this point, helps me keep track of everything, and it's all going to be contained within this one restyle feature, which is really what we want. And then from there, we have different options for analyzing the surfaces. So we can take a look at our diagnostic tool here, which allows me to see things like the deviations away from the original area that we started with, and allows us to get a better understanding of which areas that we're pretty close with, which areas that we might be further off with, any areas that you're more concerned with. You can see the effect of any of the changes that you're making here. In my case, I'm pretty much happy with the results that I'm getting here. So let's move on to the next section that we have. And just like we did on the first surface, I'm going to start by moving along the first section curve that we have going down the middle of our part, or our scan data, just simply laying out some points that are going to follow along that path that we want to go. And once we have that, we can again project that back onto the center plane just to make sure that we're aligned well there. And now we're going to go right along the outside of that section that we want to place our next surface down. And what you'll notice as I'm going through and doing this is I'm leaving a little bit of distance between my curve and the outer side edge of that geometry. And that's because I'm going to go through and merge these different sections later on and round off those areas. So in our case, there's no need for us to try to align it up perfectly in that case. Right, and once we have that outer loop defined, we can go ahead and specify the domain of points there in the middle again. So again, those are just going to be all the points that are bound by those different curves that we laid out, and allows us to build out surfaces based upon that, do diagnostics on that domain of points that we want to create the surface based on. And we could analyze that further. But before we do that, let's go ahead and add in another controlling curve going through the middle of that area. And then we'll just go right up into our different polynomial surface options, which we have a lot of, depending on the use case that you're working around. Let's go ahead and build the surface based off of that. All right, so different techniques that we could work with there. Again, set them all up the way that you want, but you still have the ability to modify them and analyze them as we go along. So not really going to be the typical Creo workflow that you would normally see with the parent-child relationship between all the different parts of the features. It's using that faceted geometry to create the domains or the curves or the surfaces. But once they're built, you're really free to work with them however you want. You can change around that geometry without affecting anything else down the line. So it's all going to be within that one restyle feature. So you can clearly see you can go through, build out the surfaces, analyze them to see what you got, really based off of that point cloud data that you started with, but you're not tied to that if you don't like to be. So you can go ahead and keep moving on to some other areas of the point cloud data that we started with here. Let's go ahead and create another surface down here. And everything that I'm building out here is just going to be, like I mentioned, under basically managed under that one restyle feature. You don't have the hassle of having all these different curves, all these different surfaces in the model tree, where it's a bit more difficult to manage and you're running the risk of having these change and messing things up from what you're creating here. Instead, we are able to have it all managed from within one restyle feature, but you still have the restyle tree where you can see everything that we've created, but it's much more free flowing, just simply using that faceted geometry as a jump off point that we can work with and make any modifications that we might need to as we keep moving along. And this one might be a little bit more simple of a curve. So we just go ahead and specify those 4 curves to build our surface in that case. And we can go ahead and project that onto our faceted geometry and keep moving on. So that's what you'll see is there's lots of different ways of building out these different surfaces. Even if you wanted to just do 4 corners where we just make a surface simply off of 4 points that we have in space, and then have options for increasing that complexity as you go along. And then finally, we can project that surface onto our point cloud data to match it up a little bit better, and we're good to go. Maybe the next area is a little bit more complex. Maybe you have a little bit finer detail from within here. So in our case, we can put down a few controlling curves instead of simply the 4 corners like we did in the last one. And that's really something that you'll get the hang of once you start doing this, is what types of surfaces work well for the geometry that you oftentimes work with. Maybe you just use 1 or 2 types of surfaces normally. Maybe you use all the different types of polynomial surfaces or analytical surfaces, lots of different options that we have and different tools that you have available for you while you're working. So it's really up to you. You have all the different tools available and you just simply go through, place them, analyze it, see if you like what you got. If not, you go back and make any changes that you might want. Now I'm pretty much happy with the new surfaces. Like you see, you can still go back and modify anything that you want to change. You can extend this one out if you want to merge it in with some of those other surfaces later on in the process. In general, it's very easy to work with these different surfaces as you go along, even if there's areas that you might have forgotten about. So like in the back here, there's an area that maybe we forgot to cover. We can just go right back at any point and go ahead and do that. And this could be a very quick process. If you want to follow tight right along those edges, you can change them up if you like to. There's nothing telling you you have to match up with the point cloud data unless you really do want to line up exactly with what you scanned in there. But from within here, what I want to do in this case is actually take the domain that's contained from within those curves. And instead of how I did it previously by building out the surface from those curves, we can instead build it out straight from a domain of points itself. So still different options like you can see here for controlling that surface or defining the direction or looking at the different dimensions that you created. But we can really either keep that or change them up for however you might want it there. So it's up to you still. You still have your standard types of modeling in terms of creating splines if you'd like to build it from there. So you can combine different types from within that as well. And in this case, I do really want to follow close along that back edge and make it into a nice, smooth, extended curve in this case. Right. And just like we're able to do with any of those other surfaces, we can still extend it or work with it however we might need to. Just go ahead and make sure that it overlaps on the other geometry that we want to merge it in with. And I think that's looking pretty good for my back surface. All right, so let's go ahead back into our isometric view here, and I'll just change some of the layers to change the display and clean up the area that we're working with. Now that we have all the different surfaces that we need, we can go ahead and hide the curves that we added in to create them and just work now from these surfaces. All right, so what we're going to do from this point now forward is once we have the basic shape outlined, what we're going to do is treat them just like standard Creo surfaces and get these put together into a larger quilt. So in this case, let's go ahead and extend these different surfaces past one another, essentially just looking to overlap everything. And once you have everything overlapping, what you can do is trim down on the extra that's left over from that, just leaving us with a nice connection at this edge here. There we go, it's looking pretty good. So once we have that extended, let's go ahead and merge them together. And once they've been overlapped, we will then go ahead and take that and round that off just to make sure that we have a nice smooth transition between those different surfaces that we created. And that's what, again, one of the nice things about this is once you have your restyle feature, it really just goes back into your standard Creo functionality that you're used to. You can use your extends, merges, rounds, anything that you might normally use for creating or editing surfaces in Creo. You can go ahead and do that right here as well. So go ahead and do the same thing down here on the side of the model and pretty much do the same thing that we did up on the top. Bottom, go ahead and merge these as well and start to work towards a larger quilt in that sense. Go ahead and round those off to get a smoother transition as well. And again, lots of different options that you have from a rounding sense from within Creo as well. Creo is very powerful whenever it comes to laying out rounds on your models. All right, and it's looking pretty good. Even if there's a surface in the back that we forgot from before, right? We can go ahead and work with that if we really need to. But in this case, we can just go ahead and mirror that because it's going to be symmetric about that center plane. And that's starting to look pretty good. And again, we can tie this back in with some of the other surfaces that we had previously for that seat cover. Merge them like that we did with the rest of the quilt. And that's looking good. And we can, again, start to round that off. Go ahead and do a corridor around it in this case. Lots of different options that you have there. But really just going to show that this ties back in with all of your standard Creo parametric functionality that you're already used to using. It's just going to be based off of that and really tie in very well with that as well. And again, the surface in the back, you can do any of that work in sequence, or if it's later on in the process and if there's even something you forgot, like I mentioned, you can go back and still do your merging, do your rounding, do your different Boolean operations that you might need to get to the final service that you're looking to take forward and work with from that point here. Let's go ahead and merge those in. Round off our final area here. And that's looking good. So really goes to show, even though we built all these different surfaces within that one restyle feature, you're still able to go through and work with them on an individual level at any point in the process later on down the road. And so again, you can start with a decent bit of complexity from that point cloud data, but the restyle feature and reverse engineering in general is going to make it very straightforward to take all those different points and turn them into some real curvature continuous surfaces that we have here in Creo that we can work with. So not only in the context of my assembly, but again, in the real world as well. So these are parts that we could put on a mill, we could extrude. In this case, it would probably making a cast for it, but however you want to do it, you're able to go through and create that from what we're building out here from within reverse engineering. All right, so again, if you have any questions, feel free to drop those in to the Q&A box. If there's anything that you might want us to follow up with as well, we can definitely do that. And while you're doing that, just want to cover very quickly just some of the main benefits that we're really getting and what we're seeing from people that are using this tool out in the industry. So there's a lot of benefits that you're going to have. First and foremost is reducing time to market. The faster you can get from point cloud data to real manufacturable surfaces, that's going to get you into production that much faster and get you something that's going to be also at a higher quality as well. And we also see people reducing product development costs, where you can take some of the geometry, even if it's fairly complex, where in the past it would have been a very painstaking process to recreate that geometry. It's a lot more straightforward here working with the reverse engineering extension. And also at the end of the day, you're not taking shortcuts to build the best possible models with that highest quality. You can take something that was started in the real world with no design intent and really go through and get that built out from within Creo and have that design intent that you can work with going forward. All right, so that covers everything that I wanted to touch on today, and I can pass it over to you, Rob.
Excellent. Thank you. Thank you very much. So what I did was I wanted to say thank you to the person who had, I guess, tapped in that we're doing a nice job. So thank you very much, Don, for your input. It's much appreciated. As I mentioned earlier, the recording will be sent out to everybody sometime either later today or first thing tomorrow. Next Wednesday, we're having a webinar on Wednesday afternoon, noon. We're going to have a webinar on Windchill, how Windchill manages multiple CAD systems, not just Creo, but other CAD systems like Siemens NX, SolidWorks, Unigraphics, CATIA, and all that good stuff. It's also going to cover a little bit of BOM management. And then on the 21st, we're going to have our last webinar of the year, and we're going to talk about a capability that is already currently available in Creo, the Design Exploration Extension. So what I like to do also with these webinars has helped to give people some insight to what you can already do in Creo with the license that you have. So design exploration extension is pretty cool. And I hope this, that both of these webinars coming up will add some value. If you want to see a custom demo on anything wind chill, anything Creo, augmented reality with PTC, feel free to get in touch with us. So we do have a question that just came in. So I'm going to shift gears and just answer the question here, Paul. So when creating those surfaces and the rounds, was that deviating from the actual part's dimensions?
In that case, it was. And the reason that it was in that case is because sometimes whenever you're scanning in more rounded geometry, you don't want to pull straight from, say, for example, you have a surface that has a chamfer round on it. The scan data that you're oftentimes bringing in isn't going to be exactly the cleanest data. So what we could do is essentially just build off of it and then do your rounding from within Creo instead of trying to work directly from what was scanned in. So you could, if you wanted to, we could have just built it straight from the scan point cloud that was brought in and could have aligned exactly with the scan data that was brought in, or you could do that after the fact and just use Creo functionality to get there. So ultimately, yes, we're getting to the same dimensions that our physical part out in the real world would have. So say, for example, you took a caliper and measured all the different dimensions that you're taking from within the model, it would match up with that. But it's up to you whether or not you're taking it and building that directly and exactly from the point cloud, or whether or not you want to let Creo do some of that work for you from a feature-based perspective. Two different ways that you could go about it in that sense. So in our case, yes, we did use some of the Creo functionality to get to those dimensions outside of just taking it straight from that point cloud.
I think this is a request. Future webinar on drawing sign-off approvals, functionality and wind chill, request for change form, engineering change order. Yeah. Good, duly noted, Don. Let me see what I can let me see what we can come up with regarding I know we just had a change management webinar for wind chill. But if we need to get in specifics, we may be able to help you with what you're asking, or we can just I'll discuss with Paul and see and go to what we just recently recorded. Maybe that's also in there. Next question: what function did you use to find the center of your point cloud?
Yeah, so we had our coordinate system that's based off of the point cloud data that we brought in, and then we just tied that in with the overall coordinate system for the assembly or the part that we're working with. So in our case, it wasn't based off of the exact center of the point cloud. We just simply had a coordinate system that we used to align it in with the rest of the geometry that we started with. For the bottom and the sides of that seat cover, it was tied in, that coordinate system for that overall assembly was aligned with the coordinate system for the point cloud data that we brought in. So not necessarily the very center of the point cloud, but just a point of reference for aligning it from within the context of Creo.
Good deal. Good questions. Good engagement. So as I was mentioning, if you want to see any type of demo on Creo or wind chill to anything that's specific, we can gladly do that for you. And all you have to do is just send me an email. You can reply to the emails that come from me regarding the invitations to these webinars. Or you can contact us at info@3hti.com, and we're more than happy to help you. So I will get back to you, Don, on your requests and see what we can do to get you some more information and help you out, or do a custom, just include those topics in an upcoming webinar. So everyone, thanks again for being on today. Paul, thanks a lot for doing a great job as always, and enjoy the rest of your week, everybody. Take care.